Welcome to physics online session. In this class we'll discuss example problems from ray optics and optical instruments. Okay, and this is the first example problem 9.1. so suppose I'll read this question first. Suppose that lower half of a concave mirror's reflecting surface, the figure is not represented here, I'll draw the figure. This is a concave mirror. This is a concave mirror. So what was happened to this concave mirror? So here lower half of the concave mirror's reflecting surface is covered with an opaque object. So if you place an opaque object here, if you place a book or any opaque object, book like any opaque object, so what effect will this have on the image of an object placed in front of a mirror? Before you place any opaque object, for example, this is an object located, some person is standing in front of a concave mirror, he will get its he can see his image in the concave mirror. Okay, so what will happen when the half of the portion of this concave mirror covered with a non reflective surface? Okay, so here nothing will happen to the size of the image. So if you cover the half of the mirror, some people may think that we cannot see half portion of the object, so that is wrong concept. So we will see the entire image, but the difference is you will see the intensity of the image will decreases. Okay, so the no change, answer is no change in the image, no change in the image, just the size, just the intensity of image become half. Okay, so this is answer to this 9.1 example. Next example number 9.2. This is a mobile phone lies along the principal axis of a concave mirror. Okay, this is a concave mirror and we are placing a mobile phone here. This is a mobile phone, okay, placed along the principal axis of a concave mirror. Show by a suitable diagram, this is the mobile phone, the formation of its image. Okay, and this is the formation of image. Explain why the magnification is not uniform. So why we are getting image of different sizes at different locations, why the magnification is not uniform? Will the distortion of the image depend on the location of the phone with respect to the mirror? Okay, so here it is not a point object. Okay, it is an extended object. Okay, so before going to answer this question, first we need to know some points. When the object and image, when you know some points regarding the position of object and image. When object is located at infinity, you will get the image at the focus. Yes sir. And when object is placed beyond the center of curvature, beyond C, you will get the image in between C and F, center of curvature and focus. This is the first and second point. And third point, if you place if object is at C, so image also formed at C of same size. Here when object is placed beyond C, you will get the diminished image between C and F. So in place of when you place object at center of curvature, image is also observed at the center of curvature but inverted image. You will get the inverted image. And the fourth one, if you place an object between F and C, you will get the image behind the center of curvature. Okay, so a magnified image, you will get magnified image here. But when you place an object at the focus, image will be at infinity. Okay, so based on this points, we will try to answer why the magnification is different at different locations. Okay, this is this is an object, so I'm taking 3 points from this object. So here from point A, so we are taking 1 2 I think 2 light rays from this object, from this point, from the tip of this object, one of the tip of this object. So there are 2 light rays, one is moving parallel. So when parallel ray of light after reflection from this concave mirror will pass through focus. Okay, and I am taking 2 light rays from this object, from point from one point of this object, that is from A. They are leaving from this object. I took 2 light rays that are those are leaving from this object. So after reflection, once again they will meet at a point. At some points there will get the image of A. Okay, look at these light rays, incident light rays 1 and 2. One is parallel. Okay, so will reflect and passes through focus like this. Another is passing through, one is passing through parallel, and after reflection passes through focus. Okay, and other is passing through focus and become parallel. So and these 2 light rays again meet at this point. So there you will get the image of A. Okay, so image of A. Okay, and what about the image of C? So C is a center of curvature. So if you take one tip, another position of this mobile, so here we can take one light ray from this position. So where do you get the image? So at the center of curvature only. So here I am taking this position. Okay, I am taking one light ray, another light ray from position B, so they will come to meet. So I am taking one light ray that is parallel. Okay, so after reflection it comes to focus at this point. Okay, here you will get the image of BC as B dash is C. The size of this image is same as that of object. Why? Because this portion of the mobile lies on the center of curvature. You will get the same image of same size. Okay, but this portion is in between C and F. When you place an object in between C and F, you will get the image of that object beyond the center of curvature. So this is an portion of the object between center of curvature and focus. The image of this portion will be the magnified image of this portion is obtained here. That is why the magnification is different at different locations. Okay, so here the magnification and since the magnification is different at different location, definitely the shape of the image will different at different locations. So it is said to be distorted image. We will get a distorted image of the mobile. Okay, the next one, third question, 9.3, example number 9.3. So an object is placed at a 10 centimeter 5 centimeter in front of a concave mirror. The radius of curvature of this concave mirror is given as 15 centimeter. We need to find the position, nature and magnification of the image in each case. Okay, so we will solve this problem. No, this is a solution. And what is given to us? It is given that a radius of curvature of this concave mirror. So given radius of radius of curvature of concave mirror, radius of curvature of concave mirror. So r is equals to 15 centimeter. Okay, for concave mirror radius of curvature is taken as negative, for convex mirror it is positive. Why? Because this distance is measured against the direction of the incident light. Okay, now I'll draw the convex mirror here, and this is the convex mirror. Okay, and I'll represent the principal axis. This is a principal axis, and this, let it be the focus, let it be the center of curvature, and this is the r radius of curvature 15 centimeter measured from the pole. This is the pole. Okay, so it is given that r is equals to minus 15 centimeter. Therefore the focal length is f is equals to r by 2, that is equals to minus 15 by 2, that is equals to minus 7.5 centimeters. Okay, now we need to find the position, nature and magnification of the image when object is at 10 centimeter and also at 5 centimeter from the concave mirror. First we will discuss the first case, when object is at 10 centimeters. Okay, in that case object distance u is equals to minus 10 centimeter. Okay, because object distance measured against the direction of the incident light. Now u equals to minus 10 centimeter, and here we need, first I need to find the image distance. Focal length is given to us, so we know that I'll use mirror formula. You know that mirror formula. So 1 by f is equals to 1 by v plus 1 by u. So the above equation can also be written as we need to find an expression for v. So I'll take 1 by v common from this expression. Simply v 1 by 1 divided by v equals to 1 by f minus 1 by u. Okay, so that implies 1 by v is equals to and what is LCM? U into f is LCM. We can write it as u minus f. Therefore we can write v as u into f by u minus f. Okay, so this is the image distance, expression of image distance. Okay, you can use directly this formula to find the image in case of mirrors. Okay, so I'll find the position of the image here. V is equals to u, object distance is minus 10 and focal length is minus 7.5 centimeters, and again u minus f minus 10 minus of minus 7.5 centimeter. No need to write unit here. Okay, so image distance is v equals to what do you get? Minus into minus plus, so we'll get in the numerator we'll get 75 divided by in the denominator minus 10 plus 7.5 will get minus 2.5, that is equals to minus 750 by 25. So we'll get the image distance as v is equals to minus 30 centimeters. This is the position of the image. Okay, so where we have placed an object is placed at 30 centimeter. Okay, somewhere here this is 15 centimeters and position of the center of curvature, this is 7.5, somewhere it is located. So this is the position of the object, and where we got the image of this object behind the center of curvature. So and this is the position of the image, v equals to 30 centimeter. Okay, this is the object at 10 centimeter. This is the image. Okay, now we have answered one question. We find the position of the image, and we need to find its magnification also, and therefore magnification m is equals to, where there is a formula, minus v by u. So minus of minus 30 by u is minus 10 centimeter. So m is equals to what we got, m equals to minus into minus plus 30 by minus 10, you will get minus 3 finally. So here magnification is greater than 1, so definitely it is a magnified image. Negative sign represent the image is inverted, so you can say that the image is a real magnified and inverted. This is the nature of the image. You will get magnified real image in inverted position. This is the first part of this second question. Now the second location of the object, when object is located at 5 centimeters. So u equal minus 5 centimeters. What is the position and nature of the image? Here we'll find here. Again we use the same formula. I'm using direct formula. V is equals to u into f by u minus f. So here u is equals to minus 5 into f is minus 7.5 divided by u is minus 5 minus of minus 7.5. So v equals to here minus 5 into, so what do you get? I think 7 5 is 35, 350 and 25, you will get 37.5 plus 37.5 in the numerator, and denominator what do you get? Minus into minus plus, so minus here minus 5 plus 7.5, here we will get plus, not minus, is the bigger one, so plus 7.5 will get plus 2.5 here, and here we will get v is equals to 375 by 25, so 25 ones, so what is the remaining difference is 12, so we will get 125 means 125 is 5 is 125, so we'll get the image at 15 centimeters. So v is equals to, we'll get the image at 15 centimeter, v equals to 15 centimeters. Okay, this is the position of the image. And what about the magnification? Therefore magnification is equals to, magnification m is equals to minus v by u, that is equals to minus v is 15 centimeters divided by u is minus 10 centimeter. So we'll get the magnification as m is equals to plus 1.5. so here we'll get a virtual image, virtual. Why? Because image is formed behind the mirror. Okay, so where the object is located in the second case, object is located at 5 centimeters, so this is 5 centimeter, you will get the image of this object behind the mirror. So that is why this is a virtual image, not the real image. Virtual erect straight image, erect and magnified image is obtained behind the mirror. Okay, and the next question, suppose while sitting in a parked car, this is a parked car, you notice a jogger, a person is jogging. So this is a jogger is approaching towards you in a side view mirror. You can see the jogger here. Side view mirror of radius of curvature r is equals to 2 meters. So r is equals to, given what is given to us, given radius of curvature so r is equals to 2 meters. Okay, and if the jogger is running at a speed of a jogger is given, how fast the image of the jogger appears to move when the jogger is at 39 meters and 29 meters and 19 meters. Okay, now first, since it is a mirror, so we use mirror formula to find the speed of the jogger. So now in the first case, when the jogger is at 39 meters, therefore the object distance u is equals to minus 39 meters. Okay, and what is given to us? Radius of curvature. Therefore focal length of the convex mirror is positive, radius of curvature is also positive, because it is a convex mirror. For concave mirror both are negative. F is equals to 1 meter. Okay, so and we need to find the position of the image. What is the position of the image? We can find the position by using this formula, u into f by u minus f. This is a mirror equation. In the above previous problem we have discussed this relation, where u equals to minus 39 into focal length is 1 meter, and minus 39 minus 1, that is equals to minus 39 by minus 40, will get finally 39 by 40 meters. Okay, so this is the image distance. Okay, distance of image from this convex mirror. Okay, initially when the jogger is at 39 centimeters. Okay, when u is equals to minus 39 meters, we got v as 39 by 40 meters. Okay, in the second case, for example, after it is given that the jogger, it is also given that jogger is moving with the constant speed. Okay, so and that is given as I think 5 meter per second is the speed of the jogger. In 1 second, jogger covers 5 meters. So after 1 second, after 1 second, the position of the jogger is equals to what? U is equals to minus 39 plus 5. Why? Because he is moving towards the mirror, so this distance decreases, so we will get minus 34 meters. Okay, now when the jogger after second is at 34 meters, what would be the image distance? So v is equals, once again use the same formula, u into f by u minus f is equals to u is here u is minus 34 into 1, so divided by minus 34 minus 1, you will get minus 34 by minus 35 meters. Okay, now this is a new position of the jogger. What is the now I want to find the distance no, not distance. I will write the what is the shift in the image, shift in the position of the image, position of the image in 1 second, in 1 second. What is that? So you have to subtract these two, that is 39 by 40. Actually this is minus plus. Okay, this is plus 39 by 40 minus, sorry, 39 by 40 minus 34 by 35. This is a shift in the position. After simplification you will get a 1 by 280. Okay, therefore the speed of the image of Jagger will be 1 by 280 meter per second. Okay, so this is the speed of the Jagger. The Jagger appears to be coming with a speed of 1 by 280 meter per second to an observer in the car. Okay, next the second case, when the object is at what is the second position? Second position is 29 meters, 19 meters and 9 meters. Okay, when initially Jagger is at 29 meters, 19 meters and 9 meters. Okay, if you follow the same procedure you will get the image distance. I am not solving, I am leaving it to you. So just substitute 29 in this case here, 29 into 1 by 29 minus 29 minus 1, you will get one relation, and you will get image and object distances. So since the speed of the Jagger is constant, after 1 second the speed of the Jagger will be what? You in that case you will get minus 29 plus 5 minus 24, like that you will get 24 by 25. Okay, after simplification you will get the speeds as the speeds of image of Jagger will be 1 by 150 meter per second when it is at 29 meters initially, and 1 by 60 meter per second when the Jagger is at 19 meters, and it is about 1 by 10 meter per second and Jagger is at 9 meters. So here what do you observe here? Since even though the speed of the Jagger is constant, the image of the Jagger appears to be the speed of the image of the Jagger appears to be increases. So speed of image of the Jagger appears to be increasing, yes or no? Okay, so this is about the 9.4 example problem. And the next one, the Earth takes, very simple problem. Earth takes a solution. Earth takes 24 hours to rotate once about the axis. It takes 24 hours to complete one rotation about its own axis. Okay, so time for complete rotation is t is equals to 24 hours. Okay, therefore for 360 degrees of rotation, for one rotation there is 360 degree. For 360 to rotate 360 degrees rotation, it takes 24 hours. Okay, so it is asked to find how much time does this sun take to shift to by 1 degree. Okay, when earth rotates 360, the sun also rotate 360 degrees in 24 hours. So therefore for 1 degree rotation, the sun takes 24 hours, 24 hours by 360, 24 hours by 360. Therefore the answer is 24 into 60 minutes, 1 hour equals to 60 minutes by 360. Okay, 66 360, so 6 4s are 24, so the answer is 4 minutes. Easy question. Okay, the next question is 9.6. so light from a point source in air falls on a spherical glass surface. So imagine a spherical glass surface. Okay, this is a spherical refracting surface, spherical glass surface. Okay, I'm solving this problem. Okay, and the refractive index is equals to 1.5, and the radius of curvature, this is the principal axis, let it be, this is center of curvature, this is a focus, and the radius of curvature r is equals to, it is given as 20 centimeter, and this distance is measured from pole to center of curvature, and it is taken as positive. Why? Because light from point source falls on the glass surface. So here the point source, this is a point source, light is coming from this point source, it is moving towards right, so we are also measuring the radius of curvature in the direction of light, so it is taken as positive. The distance of light source from the glass surface is 100 centimeter. The object distance u is equals to minus 100 centimeters. What is the position of the image? So given what is given to us, I'll write neatly here, given that position of the image, position of object, so u is equals to minus 10 centimeters. Okay, and also given the radius of curvature, r is equals to plus 20 centimeters, and okay, and refractive index n is equals to 1.5. We need to answer these questions. We know that formula for curved surface, is n2 by the image distance minus n1 refractive index of first medium by object distance equals to n2 minus n1 by r, simply r, not r1, only one refracting surface here. What is n2? Where n2 is equals to the glass medium refractive index is given that 1.5, n1 is air refractive index is 1. Okay, substitute all the known values, we will get 1.5 divided by v image distance, and what is asked to find out what is the position of the image, so that is what we need to find. So I will keep it v only, minus n1 is 1 by u, where the object is located at 100 centimeters, so it is minus 100 is equals to n2 minus n1, think but 1.5 minus 1 by r, the radius of curvature is given as 20 centimeter, and it is 1.5 by v plus 1 by 100 is equals to 0.5 by 20. Okay, now we can simplify it as 1.5 by v is equals to we can write it as 5 by 5 by 200 minus 1 by 100, that implies 1.5 by V is equals to we'll get it as 200, 5 minus 2, that implies 1.5 is equals to 1.5 by V equals to 3 by 200, so we'll get as V equals to 1.5 into 200 by 3. Okay, so V equals to 1.5 2's 3, so we'll get V equals to 2 1's 2 100's V equals to 100 centimeters. The image distance is 100 centimeters. Okay, so the next problem is a musician is during a show makes a glass lens with a refractive index of I'll take another pen, refractive index of n equals to 1.47 that was disappeared in a liquid. What is the refractive index of the liquid? So could the liquid be water? Okay, so here given that the refractive index of our lens, glass lens P is n is equals to 1.47. okay, so it was disappeared in a liquid of refractive index. Okay, so when it disappears means we cannot see them separate. Okay, so here the glass lens is placed in another liquid, but we cannot see that glass lens because what is the reason behind? So even if the refractive index of glass and liquid, if both are same, then we cannot differentiate the two objects. Light doesn't bend differently from those two media. That is why we can see them as one media. So the refractive index, if the refractive index of the liquid, liquid is same as that of glass, okay, so we can see we cannot see the two media separately, so this is the reason why it disappears. Okay, but the medium that what is the liquid here? Liquid is not water. Why? Because refractive index of water is 1.33, but here the refractive index of the glass is 1.7. so the liquid could be glycerin, so whose refractive index is about 1.47. okay, this is example number 9.7.